So, ladies and gentlemen, good morning and welcome. The markets are demanding ever faster, cheaper, and more customized machinery. And I'm going to show you today how you can be more cost competitive with data-driven manufacturing enabled by intelligent production equipment from Bosch Manufacturing Solutions, or BMG. My name is Andreas Braun. I'm Head of Engineering at BMG. Welcome, very welcome to this talk. Now, faster, cheaper, more customized. These are things that matter a lot also to electronics manufacturing. And I'm going to give you some examples. Time to market matters. We see requirements to machine builders of less than 12 months as delivery time in Europe, and even more so in Asia with typically less than 6 months. We see, especially in the realm of power electronics, we see a huge variance of shape, sizes, and even process sequences. So machinery needs to deal with this variance, and I'm going to talk also today about how our processes deal with varying requirements. And last, but certainly not least, costs matter. Costs are terribly important, but we are not going to look only at investment, but we are also looking at how equipment performs in terms of cost over lifetime. And therefore, reliable performance matters a lot too. Now, when it comes to reliable performance, downtime is an issue. And if you look at these statistics here, downtime is one of the biggest issues out there. Many manufacturers claim downtime is their biggest source of operational costs. We see on average about 300 hours of unplanned downtime, and the average cost of a downtime event can run up in the six-figure dollar realm. And if we look at the root causes of the downtime, equipment matters and equipment failure matters, but much more so is related to manual data entries. We see the 50% there, and also administrative delays, so the way how the organization reacts to issues in the production line. And therefore, I'm going to talk also today about how we have tools that help you run the equipment in a reliable way. Before I go there, let me introduce who we are. We are Bosch Manufacturing Solutions. We are a global industrialization partner and turnkey special machinery provider. We have more than 30 years of experience in the industry under our belt, and we have delivered more than 4,000 assembly and testing systems. On top of that, more than 10,000 small and services projects, and we are able to tailor the automation level to your needs, from manual solutions to semi-manual solution, and of course fully automated solutions as well. And we digitize in a consequent way. We have a digital planning process, we use digital engineering solutions, and we provide you with modules, applications that help you run the equipment out there on the shop floor with insights on how to do that best. We are close to you with more than 17 locations on the globe. We have a vast portfolio with a full line approach and about 1,900 smart people that work for us. Our turnover is in the realm of 700 million euro as of 2024. Now, what is the basis of what we do? And I'm going to talk about 4 pillars today. We provide engineering competence also as consulting services. We pride ourselves with our deep understanding of advanced manufacturing processes and technologies. We provide intelligent and digital solutions to run the equipment, and of course services along the entire product life cycle. Now, I'm going to delve first into the realm of the advanced manufacturing technologies and processes. In the context of electronics manufacturing, a lot of processes matter, and we master a vast range of processes in our machinery that we deliver. I will not read through all of this, but we master joining processes, we master handling processes, we master measurement and testing processes, and further relevant processes, be it laser structuring or plasma cleaning, should that matter to you. And I'm going to show you 3 examples of processes that are used quite widely in the realm of electronics manufacturing. The first example is dispensing. We have quite a bit of experience with dispensing, proven reliability with more than 200 units in the field, and we can deal with variety. We can deal with quantities ranging from a few milligrams to kilograms. We can deal with sizes from 100 millimeters squared to 600 millimeters squared, and we can provide excellent repeatability and high speeds exceeding 1.5 meters per second to you should you need this. On top of that, we can customize that with automatic optical inspection systems that provide online quality checks on the fly in the same machine shortly after the masses are dispensed. Second process is laser welding. Laser welding goes a long way back. At Bosch Manufacturing Solution, we have deep expertise in laser welding. And again, we can deal with variety. We have flexible optics available that we can use to serve flat geometries, but also 3D geometries. We can deal with different thickness requirements from a few tens of microns to millimeters. We have proven clamping solutions that come without any damage to your product, are damage-free in the long run. And we also have solutions that are virtually emission-free. So all the residues that get generated in a laser welding process, we remove them reliably and therefore have a virtually emission-free process. Again, variety. We are able to deal with different material combinations, be it copper-copper, be it steel-steel, copper-steel, copper-aluminum. We master it. You can come to us and we provide reliable manufacturing machines. And as a last example, something that is very special to electronics manufacturing that we see increasingly is flex foil handling, a very delicate process where a very thin foil is inserted or later welded to a PCB. Here we provide automated catching solutions, guiding and insertion, even sensors to assist with a particular gentle way of inserting those foils, and integrated controls for alignment and reliability. Now, when it comes to speed and cost and reliability, it's not only about the manufacturing processes. It's also about what we do on the engineering side and what we do in terms of data-driven manufacturing. And I'm first going to talk about digital engineering. So what do we do in engineering? So as we build physical equipment for the real world on top of the slide, we also take a journey in the virtual world. And in this engineering journey, we aim to get feedback on our solutions as early as possible to learn and to improve quickly in the engineering process. We look at the digital twin to already get an understanding if the model makes sense. We look at simulations, and I'm going to show you some examples to check for collisions, to check kinematics, and to check communications. And we later on also go to data-driven manufacturing to provide you with insights on how to best run our equipment. Let me first show you what we do in terms of digital twin and simulations. I'm going to show you 2 kinds of simulations here. The first simulation that I'm going to show is happening very early in the process, and it's happening on line level. So this is done before the design is even detailed. Very early, we look at line concepts and we run long-term models that amount to the equivalent of months and sometimes even years of manufacturing. We check the line logic, we check the line performance, cycle time, throughput time, and we minimize investments in physical things like workpiece carriers, AGVs, and AMRs should they play a role. We also check for inter-machine dependencies, and this is happening in electronics a lot. For instance, in a dispensing process, you care about the time between the moment the mass is dispensed on the product and when the partner is coming to the product and you close a gluing connection. And this time cannot be unlimited. You have a certain time limit here. And we already check for this in a very early stage of the engineering process. We also remove concept weaknesses like bottlenecks because we understand the failure statistics of our machines in the shop floor and can protect bottlenecks, for instance. The results are lean layouts, reduced investments, robust intralogistics, and a fast ramp up. So again, this helps a lot when it comes to speed. Now, the second simulation I'm going to show is something that we call virtual commissioning, virtuelle Inbetriebnahme in German. This is happening later and is happening at a layer below. It's happening on machine level and it's happening before the equipment is built. So while, for instance, procurement is happening, we strive to have the software ready, have the PLC code ready, and run this software against a model of our machine. And we can check a lot at this stage. We can check all the kinematics, all the movements. Are there any collisions? Are there any improvements to be made in terms of cycle time? We can check robotic functions. We can run special modes, calibration, changeovers. And certainly not least important here, we can check the data handling. So even before the equipment comes physically into existence, we can check whether our software communicates properly with the IT of our customers. And this is super helpful because that is typically a point where you can run into major problems later on, and we do that before the equipment is physically there on the shop floor. And this is a game changer for us. We push this a lot. We short commissioning times by up to 2 months. We see a dramatic reduction in failure costs in the commissioning and ramp-up phase. And we can make sure that the machinery is well behaved in all kinds of exceptional situations because we test them. We can virtually test whether an operator hits the stop button at any moment in time during the sequence and that the machinery thus behaves in a controlled way. And last and again not least, we are ready for further lifecycle optimizations. We have the digital model ready, and should you require a modification of a Bosch Manufacturing Solutions line later on, we can do that with a minimum amount of downtime because everything can be paired offline. The model is there, we can run the software, we can check it, and we are very confident that our solutions can be put into your line on the shop floor with, again, a minimum amount of downtime and very low risks. And this is the game changer for us, or one of the game changers for us in engineering that we drive forward very aggressively. Now, in the last part of my talk, I'm going to speak about another pillar of our portfolio. This is the digital and intelligent solutions. I'm going to delve deeper into what we do here over the next minutes. So these digital solutions, they come, as I put it here, in 3 baskets. The first basket is solutions to provide all kinds of necessary connectivity. And you can see a number of controller technologies that we can connect to, but it's not only about field connectivity, it's also about connectivity at all levels of the automation pyramid. The second basket, intelligent edge as we call it, contains things like good visualizations, data analysis, prediction functionalities. So this is targeted towards experts who want to understand processes more in depth, who need maybe to adjust processes or need to run automated control loops in manufacturing with intelligent algorithms. The right-hand side baskets, the line and shop floor solutions, this is more targeted towards people running the equipment on the shop floor, assisting operators, assisting planners with good visualization, enabling quick reactions to any unforeseen things going on in the shop floor. And we have a vast portfolio of solutions out there. I'm not going to show all of them, but I'm going to show you some examples and some of them in depth. On a not so in-depth level, for digital solutions that we deploy, starting on the left-hand side with two examples from the intelligent edge. On the very left side, there is process monitoring. These are modules that allow you to visualize time series, visualize process observables to really understand what's happening in certain processes. Imagine laser welding, for instance. So you can zoom in there, you can compare curves and generate in-depth insights. And this is very helpful when speeding up root cause analysis if things go wrong, and help us also setting up machinery during the commissioning phase in a very short amount of time. The second example is an AI-based anomaly detection, where we train an AI model on time series data. This function is then able to automatically identify deviations. You do not need to hard code any classical features, but from the trained algorithms, deviations become detectable early on. You may adjust sensitivity and some parameters, and you can also issue notifications to whomever you want to address this to. So this again helps with detecting things earlier, detecting wrong trends before anything goes really awry, and reduces risks in that manner. On the right-hand side, again, solutions targeted more towards shop floor and planning personnel. I would like to mention the KPI view solution. It's an application where we have a very simple, self-explaining visualization of what's happening on the shop floor. You can fine-tune that, choose KPIs that matter to you. And it's also an IT tool that can serve as a middleware between the machines and should you have any, say, data platform in your plant, so you can pass the data through that. Very helpful in terms of transparency, very low barrier access, enables quick reactions. And on the right-hand side, two digital solutions that we call maintenance ticket system and experience share system. Together, they are a powerful tool to reduce unplanned downtime. And why is that so? This is something that you can pre-configure to issue tickets to technicians, for instance, maintenance technicians. And these tickets then come with all the error background and descriptions that the machinery can provide. But there's also the experience share part. And the experience share part is a function where solution providers, maintenance experts, for example, can enter their experiences such that should the same or similar error occur in the future, another technician can benefit from the know-how already available in the system. So you have a growing knowledge base in the context of your organization that helps you bringing down downtime. I talked about this in the beginning. Shorten your mean time to repair and build up systematic and in-depth problem-solving competence and know-how. I promised some examples where I would go a little bit more in depth, and I'm going to do that. This is an example from another industry, and I would like to show the benefits of anomaly detection and predictive maintenance here. What we are talking about here is e-drive manufacturing, in particular the stator part of the e-drive, where copper pins, relatively massive copper pins, need to be brought together and electrically brought together to provide the motor circuitry in the end. Now, these pins are relatively massive. Imagine 1.5 by 6 or 7 millimeters squared. And you can imagine the torque that it takes if you want to deform these pins. And this is what we need to do because they need to be bent into shape prior to the electrical connections that would then subsequently happen via a laser welding process. And you can see that if you look carefully here again in the movie, what is the bending result. So a lot of torque, a lot of force in these bending processes. And you can see one of those tools that does it, this tool string in the middle of the slide here. And this tool is an expensive one. And once broken, once really damaged beyond repair, it's very expensive, unplanned downtime, tool costs, and also lost pieces. So it's very beneficial if we can detect the onset of a tool damage early on, and then can take out the tool in a controlled way, save the tool so that we can repair it instead of dealing with damaged tools, broken tools that can never be repaired. And we do that also via our digital solutions. We here bring together the context from within the machinery through a connector. We add to this acoustic emission signals because a lot of information is contained within there. And by combining these signals and running our mathematics, we are able to predict failures early on and can trigger maintenance activities in time before a tool is damaged beyond repair. I'm going to skip that one for time reasons. The last thing I'm going to show you today is a more hands-on example, and I'm going to start the movie again. What you see here is the KPI view. Very simple, systematic, clear visualization, low barrier thing where here you can look at the shop floor and something is happening in that line. So you can click on that, you can find something is happening on station, what is it, C46? And there seems to be a logistics problem. And here we trigger automatic tickets. In this case, the ticket is issued first towards a setter or line leader, as it's called here. And you can configure those workflows. You can decide what channels you want to use, how often you want to repeat reminders. So very much configurable to your needs. Here the line leader or the setter decides to accept this. He adds more information to this ticket by explaining what he has observed. In this case, there's a workpiece carrier issue, and then this is forwarded to the real solution provider, in this case, a logistics expert who then can look at this. He has all the background information available and can then solve this problem with the best possible knowledge base that you can imagine. All right, I now come to the end of my talk. I have talked about faster, cheaper, and customized, and I've shown you examples how we as BMG tackle those challenges. We look at cost competitiveness, not only with an investment view, but with a total cost of ownership view along the entire life cycle. We have deep systems and manufacturing process know-how. We use early feedback loops, closed loop approaches in engineering to learn fast and be quick and fast in engineering. And last but not least, we have a huge portfolio of digital solutions out there that help you run our machinery at a high performance point through data-driven manufacturing. Therefore, thank you very much for coming here and for staying here. I would point out our booth. So we are present here. It's just next door in the building B2, booth 426. A lot of experts, some are here, are happy to go deep with you, explain to you what we do. So please don't hesitate to stop by. We are really happy to see you. Thank you for being with me here today, and I'm happy to answer questions.